Okay, in this video, I'm going to describe how to compare exponential random variables. This looks like calculating the probability that x is greater than y given both x and y are exponential random variables. You could also represent this as the probability that y is the minimum of both x and y. We can label x as the exponential distribution with a rate lambda and label y as the exponential distribution with a rate mu. We know that the PDF of x is going to be equal to lambda times e to the negative lambda of x because it's an exponential distribution. And then we can know that the PDF of y is going to be equal to mu times e to the negative mu y. Our next step is to condition on y using the law of total probability to solve for p of x, the probability that x is greater than y. So we can take the probability that x is greater than y and simplify it using the law of total probability to be the integral from 0 to infinity times the probability that x is greater than y given y is equal to y and times the PDF of y. So basically what this does is iterates across every single possible value of y and multiplies that by the PDF of y. And this will be equal to the probability that x is greater than y. We can simplify this to be the integral from 0 to infinity uh, of the probability that x is greater than y times the PDF of y again. Then, in the next step, we can simplify this p that x is greater than y using the memoryless property of exponential random variables. So the probability that x is greater than y can be simplified to e to the negative y, or e to the negative lambda y. We know this because um, this is a law for exponential random variables due to their memoryless property. So if you're not familiar with the memoryless property of exponential random variables, I would recommend going and looking up a video on that to better understand how we did this transition. From here, we can actually pull out mu over lambda plus mu by just pulling out this mu and adding a lambda plus mu onto this side. Then, if we solve for this integral, we get 1. So the answer to our probability that x is greater than y is simply equal to mu over lambda plus mu. So this is the probability that x is greater than y is equal to the rate of the exponential distribution y over the rate of the exponential distribution x plus the rate of the exponential distribution of y.